All right, let's take a look at some more problems. We're going to look at just a couple more problems here, just to make sure that everybody's feeling great about how to work these. And then we're going to do a ton of these in class. So let's read this first one. A gas expands from a volume of 17.3 cubic centimeters to 24.5 cubic centimeters. At the expanded volume, a manometer, which is something that we use to measure pressure, was used and found a pressure to be 99.3 kPa. What was the original pressure of the gas in millimeters of mercury? Okay, and that says that the temperature and the amount are both held constant. So let's list our givens. Okay, I've got a volume. I've got an original. I've got an original volume of 17.3 cubic centimeters. I've got a final volume of 24.5 cubic centimeters. And I've got a, let's see here, at the expanded volume, so that means at the final volume, my final pressure, so my P2 is 99.3 kPa. My problem wants to know what was the original pressure, so I'm looking for P1. Okay, next we want to check our units. Now, volume, it's okay for volume to be in cubic centimeters. We can do that. We know that we have to change temperature to Kelvin, but we're not dealing with Kelvin here. We're not dealing with temperature, I mean. Now, it does tell me, however, that I want my final pressure in millimeters of mercury. So I need to convert kPa to millimeters of mercury. So we're going to do 99.3 kPa. We're going to convert that to millimeters of mercury. And I know that there are 760 millimeters of mercury for every 101.33 kPa. Okay, those conversions are on your green sheet. So now I'm going to do 99.3 times 760, enter, divided by 101.33, enter, and I get 703 sig figs, so 745 millimeters of mercury that we're going to use in place of 99.3 kPa. Okay, so now I can write out my equation. I know that I'm only dealing with pressure and volume. Okay, so that means I'm dealing with Boyle's law, which is P1 V1 equals P2 V2. So now I'm just going to plug and chug, plug in what I need to. P1 is P1. V1 is 17.3 equals P2. Remember, we changed it to 745 times V2 is 24.5. And now if I'm going to get P1 by itself, I divide both sides by 17.3. And so, oh, well, let's cancel, I guess. Cancel. 745 times 24.5, enter, divided by 17.3, enter, and I get 1055 point whatever, okay? 1055, blah, 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 millimeters of mercury. Okay, now I know that I only need 2 sig figs, or 3 sig figs, so this 5 is going to round this up to a 6, so we're actually going to call this 1060 millimeters of mercury. Okay, since we were dealing with only pressure and volume here, we know that the law's name, we know this is Boyle's law. Yay, Boyle's law. All right, let's do another one. This is kind of a fun problem. This next one here, 11-10, because it gives us, we're talking about STP here. So let's look at a problem that deals with STP. So it says, what would be the volume, okay, so I already know I'm looking for volume, in liters of an 8.90 liter sample of gas at 100 degrees Celsius and 113 kPa if the conditions were changed to STP. Okay, well, let's write down what we know. We know that our original volume is 8.90 liters, so V1 is 8.90 liters. Let's see here. My original temperature, so T1, is 100 degrees Celsius. And my P1 pressure is 113 kPa. Sounds good to me. Let's see here. Then I want to know what would be the final volume. So V2 equals V2. STP, okay, we've got to remember that STP is 0 degrees Celsius, and the pressure is 1 atmosphere, okay? Now, are we dealing with atmospheres right here? No, we're not. So we want to know the standard pressure in kPa, which, of course, if you look at your green sheet, you would see that that is 101.33 kPa. Okay, my units are good except for temperature. I need to change my temperatures. So T1 is going to be 100 plus 273. So we're going to use 373 for T1. T2 is 0 plus 273. So we're going to use 273 for T2. Okay, now our equation, you're probably already noticing that we've got multiple things that are changing. It's not just a 2Z problem, now it's a 3Z problem. So we're going to use what we call the combined gas law for this problem, okay, where I've got P1 times V1 over T1 times N1 equals P2 V2 over T2 N2. Okay, now hopefully you're already noticing that our problem didn't say anything about number of moles. Okay, since it didn't say anything about number of moles, let's just get rid of that. Okay, we don't have to worry about plugging in number of moles. So what this means for us is our formula turns into P1 V1 over T1 equals P2 V2 over T2. Here's a hint. You're going to be using this formula a lot. Okay, let's plug and chug. P1 is 113 kPa. V1 is 8.90. T1 is, remember we changed it to 373. That equals P2, which is 101.33 kPa. V2 is our unknown. That's what we're looking for. And T2 is 273 Kelvin. Okay, and so now all we have to do is cross multiply. So I've got 113 times 8.90 times 273 equals 373 times 101.33 times V2. Okay, if I want to get V2 by itself, I'm going to divide both sides by 373 times 101.33. All right, now this is where you got to be careful, because if you just type into your calculator 113 times 8.90 times 273 divided by 373 times 101.33. Okay, you're going to get the wrong answer because you didn't follow order of operations. So all of the stuff on the bottom has to be in parentheses. Okay, so remember, all this is going to cancel. 373 cancels, 101.33 cancels, so we're left with V2, which is what we want to be left with. Okay, we want to be left with V2. So V2 equals, so I'm going to do 113 times 8.90 times 273 and hit enter. Then I'm going to divide by, here's the key, open parentheses. I dropped my calculator. Open parentheses. Oh no, not natural log. 373 times 101.33. Close parentheses. Enter. 7.26. Is that the correct amount of sig figs? I think so. 333. Yes. 7.26. What's my unit? Okay, what's my unit? What's my unit? Volume in, boom, liters. Okay, volume in liters. So that is what we got happening. So that's my situation. All right, that's how you do it, my friends. This law was the combined Gas law. Okay. Now, I only showed you a couple. Okay, I only showed you I think I showed you a Charles law problem. I think I showed you a Boyle's law problem, and now we've done a combined gas law problem. In class, you're going to have to differentiate between it might be a Gay-Lussac problem, it might be an Avogadro's law problem, it might be a different kind of combined gas law problem. Okay, there are many ways that these problems can be worded and used. So you're going to have to distinguish between those kinds of problems. We're going to practice a lot in class, so be ready to rock and roll, my friends.